Am I audible to all of you? Just write in the chat box. Okay. So I am sharing my today's presentation slides. Just a minute. So today we are going to start unit 4 of compiler design and this unit is basically deals with the runtime environment and the storage we are using in the compiler design subject. So first we are going to discuss the runtime environment. So to generate a target code, there is a need to know about the environment where the source program will execute. The term environment refers to a function that maps a name to the storage location, and the term state. You can here just remember two words. The term first is the term environment, and the second is the term state. And the term state refers to the function that maps a storage location to the value held there. So as you can see on your screen, an environment maps a name to an L value, means the left hand value. As you can, as we are using this like a equal to b or a equal to b plus c. As we are using this a equal to b plus c, suppose this we are going to store. So a is the left hand value because it is lies on the left hand side of equal to, and b plus c is the right hand side value as it lies on the right hand side of equal to sign. So a is written as the L value and the b plus c is written as the R value. So an environment maps a name to an L value because it is written on the left hand side of equal to sign, and a state maps the L value to an R value. So you can also see this in the diagram as this that an environment, this is the just the representation of it, right? The an environment maps the name to the storage, whereas a state maps the storage to the value. So the state basically deals with the R value, whereas the environment basically deals with the L value. So just these are the definitions of this. So environment and states are different, and assignment changes the state but not the environment. You can change the state by putting the right hand side to the left hand side, but you cannot change the environment. Now the important topics of this unit are: the first is the storage organization. So the executing target program runs in its own logical address space. As you already studied in your operating system subject, what is the logical address space? So this address space is basically generated by the CPU, means the central processing unit, in which each program value has a location. So, management and organization of this logical address space is shared between the operating system, the target machine, and the compiler. So, here we are dealing with the logical address space here, but not the physical address space. So, just remember it. Now, moving forward. the OS maps the logical address space into the physical address space. Means we are just mapping the address generated by the CPU to the address of the main memory, which is also called as the physical address space, which are usually spread throughout memory. Just a minute, some other participants are waiting in the lobby, so I am just allowing them. So, this type of mapping you already studied in your operating system subject, memory management. So, you need to just map the logical address space, the address which is generated by the CPU to the main memory, which is also called as the physical address space. Now, in compiler design, this concept we are using in the runtime environment in Unit 4. So, there are many subdivisions of this runtime memory. So, the subdivisions are: first is the program code, then the static global data, then stack is present, then the free memory is there, and then the heap data structure, which you already studied in your data structure and algorithm subject. The heap data structure, when you are when you studied the tree data structure, after that you study the heap data structure in the tree unit of data structure and algorithm. So these are the some of the subdivisions of the runtime memory. And there are some explanation to this. So, what do you mean by the program code? So, just written some explanation to this. So, program code, it refers to the static area used by the generated target code, which is fixed at compile time. So, this is fixed at the compile time. Then the static global data, it refers to the storage space for data which does not change. That's why it is called as the static, because this data space does not change during the execution of the program. Then we have the sorry, the data structure stack. So data objects allocated at the runtime. Uh, it is also used. This data set is also used in the activation record. So this is another important topic of this unit, which we are going to discuss in later. Then the free memory. So the memory area usually grows towards lower address. Then the heap data structure. So other dynamic allocation data objects at runtime is being stored in the heap data structure. So if a question has been asked the about the subdivision of runtime memory, then these are its subdivisions, and based on this, these are some uh, theory related to these subdivisions. So moving on to the next topic. Now this is very important topic of this unit. Um, the runtime storage can be subdivided to hold the different components of the executing program. So it can be done with the generated executable code, the static data objects, automated data objects, then the dynamic data objects. So storage allocation strategies, as you already studied this type of strategies in your operating system, memory management, there are some memory management allocation strategy. In the same way, we have some different storage allocation strategies in runtime environment as well. So the different ways of allocation memory are: first is the static storage allocation, then the stack storage allocation, and then the heap storage allocation. So let us discuss these storage allocation one by one. So first we are going to take the static storage allocation. So as its name suggests that it is the static storage. So in static storage allocation, names are termed to storage location. So if memory is created at compile time, then the memory will be created in static area and only once. Just remember it. In this type of storage allocation, the memory will be created in storage area and it will be created only once. But there are some limitations of this storage allocation technique. So the first limitation is static allocation supports memory allocation at compile time and deallocation after the program completes. So that is here allocation of memory is not possible during runtime because it is static. So we need to first declare the memory location before executing the program. So that's why this type of allocation of memory is not possible during the runtime. The second limitation is recursive procedures are not supported by this type of allocation. Uh, so these are some limitations of static storage allocation. All of you are getting it? Just write in the chat box so that we can proceed further. Okay. Now the second storage allocation is stack storage allocation. So in stack storage allocation, the storage is organized as a stack. So activation records are pushed and popped. So as you know that there are two operations of stack, the push and the pop operation. So it works on the basis of LIFO property, means last in first out, and this allocation supports the recursive procedure. As you already studied it, that in data structure and algorithm, that stack is being used as a data structure for recursive processes, uh, like Fibonacci series, like in Tower of Hanoi. So stack is used in recursive procedures. So the value of locals is deleted when the activation ends. Now there are some limitations of this stack storage allocation as well. So the first is the stack allocation strategy cannot be used if either of the following conditions is possible. So first is the value of local names must be retained when the activation ends. And the second is called activation outlives the caller. So you already know what does it mean by the called program and what does it mean by the caller program. You already studied in your parameter passing in C and C double plus language. Just like call by value, call by reference. So you already know that what does it mean by the called program and what does it mean by the caller. So in stack storage allocation, the limitation is there. A called activation uh, outlives the caller activation. So just remember it. Now the third type of storage allocation is the heap storage allocation. Now in heap storage allocation, it is the most flexible allocation scheme. So here allocation and deallocation of memory can be done anytime and at any place depending upon the user requirements. So there are some advantages of these heap storage allocation. The first is heap allocation is used to allocate memory to variably dynamically and when the variables are no more used, so then claim it back. So you can also once the variable are used in the program, then you can also use that variables when they are not in used. So these are the advantage of heap storage allocation. The second advantage is heap storage allocation supports the recursive procedure, just like the stack storage allocation. The third is the pre-space allocation. As you see in the subdivision diagram of runtime environment, there are free space allocation is also there. So free space allocation in heap using these type of strategies: first fit method, best fit, and the worst fit methods. You already studied in the memory management technique of um, in the operating system subject, the first fit, best fit, and the worst fit, the storage allocations. So there are some comparison between the stack allocation and the heap allocation. So as you can see on your screen, there are some properties based on which the stack and the heap allocation strategies are compared. So first is property is memory. So in the case of stack allocation, continuous blocks are there, whereas in the case of heap allocation, random blocks are there. In the case of the second property is allocation and deallocation. So in the case of stack allocation, it is done automatically, whereas in the heap allocation, it is manually done by the programmer. The third property is cost. So stack allocation is cheaper or less costly than the heap allocation, is more costly than the stack allocation. Then the implementation, the implementation in stat is hard, whereas the implementation is in heap are easy. Access time, the fifth property is access time. So in stack allocation it is faster, and in the heap allocation access time is slower in comparison to stack. Then the sixth property is drawback. um, in stat the shortage of memory is there, but in the case of heap allocation the memory fragmentation is there. As you already studied, there are two types of fragmentations are there in the memory of operating system. First is the internal fragmentation and the second is the external fragmentation. So in heap allocation fragmentation is there. The seventh property is locality of reference. So based on this is very important property. You already studied or you are going to study the locality of reference in the memory of cache memory in the cache memory topic in the compiler sorry in the computer architecture. So in the case of stack allocation, the locality of reference is excellent, whereas in heap allocation it is adequate. Then the eighth property is flexibility. So as the stack are of fixed size, but the heap is resizing is possible in the case of heap. So that's why, as you can see here, most of the properties of heap allocation are better than the stack allocation. That's why we are using the heap allocation. But when you are dealing with or you have a shortage of money, because the heap allocation is much more costlier. But in terms of money, if you have shortage of money, then you can also use the stack allocation. So all of you are getting it till now. Just write in the chat box so that we can proceed further to the next topic. Okay. Now the next important topic of this unit is activation tree. So you already studied many types of trees, and in this unit you are going to study a new type of tree which is known as the activation tree. So if the program controls flow in a sequential manner and a procedure is called, the controller is transferred to the called procedure. So when a called procedure is executed, it returns the control to the caller. So just the simple concept of the parameter passing. So this type of control flow makes it easier to represent the series of activation in the form of a tree known as the activation tree. So such type of tree is known as the activation tree. So the activation tree represents the sequence of procedure calls means which procedure is executed first, and then which is executed second. So the activation tree represents the sequence of procedure calls that corresponds to pre-order traversal. Just remember this type of traversal. It can be asked in the objective questions. So as you can see here, the sequence of procedure calls that correspond to the pre-order traversal, and the sequence of return statements to the caller corresponds to the post order traversal. So just remember which type of traversal is used when you are going there for the first time, or you are proceeding, then the pre order traversal is used. But when you are returning back, then post order traversal is used in the case of activation trees. So the activation tree depends on the runtime behavior of a program. It may be different for every program input. So the next is, so this is the example how activation tree is going to the work. So the activation tree is built in such a way that these are some of the property how we are going to build the activation tree. The first is each node represents an activation of a procedure. The second is the root corresponds to the activation of the main program. So what is root is representing? The root is representing the activation of the main program. The third point is the node for A is the parent of the node for B if and only if control flows from activation A to activation B. So just remember it. So how we are going to take the parent and the child relationship. So if if the control flows from the activation A to B, then we are going to take the parent child relationship. The fourth is the node for A is to the left of the node to the node of for B if and only if the life of A occurs before the lifetime of B. So these are the very important properties of the activation tree. So just remember these properties. What does the node represent? What does every node represent? How we develop the parent-child relationship? How we are going to assign the values from the right child to and the left child. So just remember these properties. So based on this, we are going to construct the activation tree. So here you can see on your screen an example is given. So here you can see int main. It started with the main program. Now int main. Then after that, there are some lines are written, and after that, a function is called a function, and its definition is not given. Just it is just called. It is defined here. Now here we are expanding this function after the brackets. So here we are expanding this function, and here we are writing the function explanation, and after that a b function is being explained, and in the b function we are written the return r1 statement, and after that we are going to expand the c function after the b function, and in the c function we have the return r2 statement is there. So we are going to represent these function written in the C program language in the form of activation tree. So as you can see here, according to the program, that the value of the B function here and the C function are already part of the A program. So it means that the value of the A function is dependent on the B function and the C function. So unless and until we are getting the value of B function and the C function, we are not going to calculate the value of the A function. So we are going to draw the tree of this programming, which is known as the activation tree. So this tree we are going to make. So as you can see here in the main program, we have only the function a. So here the main program is on dealing with only the function a, and the value of the a function is dependent on the value of the b function as well as the c function. So it means the b and c are the child of this parent. So we are going to, and the b, from b we are getting the value of as it is written in r1 value. A is getting the value of R1, and from C, it is written in the value of R2. So from C, A is getting the value of R2, and after that, A is going to calculate the value. So, so this function can be represented in the activation tree just like this. And finally, we get from the A value, we get the activation, the A value, because A function is written in the A value. So finally, the main gets the value small a from the a function. So just remember that the points, important points, that the nodes are basically traversed in the pre-order traversal. Means if we are calculating it, then we are taking the pre-order. Means first is the root, then the left subtree, and then the right subtree. But when we are returning it, then it takes the value of it takes the pattern. The traversal is post order. Means in the case of post order, first we are getting the value of the left subtree, then the right subtree, and after that we are getting the root value. So just remember it, and now all of you understand that how we are going to represent the program written in a C or in any language to the activation tree. So just to follow the properties, the 4 points which are we discussed earlier, we can simply construct the activation tree. So all of you understand it. Just write in the chat box so that we can proceed to the next topic. Okay. So moving on. Now the next important topic is activation records. Now, whenever a procedure is executed, its activation record is stored on the stack, also known as the control stack. So, the second name of activation record is control stack. So, just remember this word, because sometimes they also given you in the question the properties of the control stack as well. So when a procedure calls another procedure, the execution of caller is suspended until the called procedure finishes its execution. So same concept of parameter passing. As this time the activation record of the called procedure is stored on the stack. So an activation record is used to manage the information needed by a single execution of the procedure. So each procedure has its own activation records. So an activation record is pushed onto the into the stack when a procedure is called, and is popped from the stack when the control returns to the caller. So just remember these properties. So an activation record contains the following fields. So these are some of the following fields which are being contained in the activation record. So as you can see, first is the return value, or the actual parameter. So you can also just for remembrance, you can write the points 1, 2, 3, 4 here, so that you can easily remember that the at position 1 there are return value, then the actual parameters, then the control link. So these are uh, the fields, or in in terms of dbms, the attributes, which are being contained in the activation records. So just to discuss it, what does it mean? What does it mean by the return value, then the actual parameters? So return value means it is used by the called procedure to return a value to the calling procedure. Then the actual parameters. It is used by calling procedure to supply parameters to the called procedure. So these are the concept which are being used in the parameter passing. So just remember these two words, the called procedure and the calling procedure. Then the control link. The third field is control link. It points to the activation record of the caller, means the procedure which are calling. And then the fourth is the access link. So it is used to refer to non-local data. Non-local data means the sometimes called as the global data held in other activation records. As you know that there are two types of data available. One is the global data and the second is the local data. So here they are talking about the non-local data, means the global data. So the fifth field is saved machine status, means it holds the information about status of machine before the procedure is called, at which state the machine is held before the procedure is called. So you need to uh, store that locations, means at which state the registers are there or the value of the program counter before the execution start. Then the next next field is local data. So it holds the data that is local for the execution of the procedure. And the last the temporaries. So it stores the value that arises in the registers, because they are storing the in the evaluation of the expressions which cannot be put into the register. As you know that in 3 address code we are using the temporary variables. So the temporary variables are stored in the storage location known as the temporaries. So if many a times if a question is asked about the activation record, so you need to just um, write the fields which are related to the activation record and just explain those fields. So these are the seven fields which are related in the active in the one activation record. So you need to just write those fields and just explain those fields. Now the next important topic in this unit is symbol table. So as we already studied this topic in the first unit, that symbol table is attached to all the six phases of the compiler. Now here in this unit we are going in detail about the how the symbol function is using, what are the data types we are used in the symbol table for storage purpose. So the symbol table are the data structures that are used by the compiler to hold the information about the source program constructs. It is used to store information about the occurrence of various entries such as the objects, the classes, the variable names, functions, etc. So it is used by both analysis phase, that is the front end of the compiler, and the synthesis phase, which is also known as the back end of the compiler, because it is being connected with all the six phases of the compiler, whether it is in the analysis phase or it is in the synthesis phase. It is used to verify if a variable is declared or not. So it is used to determine the scope of the variable the name. It's that is lifetime is local or global. It is used to implement type checking by verifying assignment and expressions in the source code with their semantic correctness. We already discussed this semantic analysis in the unit 3. So these are some very important properties of the symbol table, and that's why we are going to use it in all the six phases of the compiler design. So just remember these important properties of the symbol table, because many a times a question has been asked about the you can say write a short note on the symbol table, so you can write this type of explanation related to the symbol table. Now moving to the next, a symbol table entry for each name can be done like this. So these are the three you can say the three constructs of a symbol table entry. You can write the symbol name, then the type, and then the attribute. So this is the general form. For example, you can write, in the case of symbol name, you can write the static. Then in the type, you can write the int type is there. Then attribute, so in the case of attribute, you can write the salary. So it means that the static int salary, you can write in these three fields, and in the same way you can also store the values of other attributes as well in the symbol table. So it is used to store the name of all the entries in a structured form at one place. You can also use this symbol table as in the form of searching. If you need to search an attribute, then you can search that attribute in the symbol table. Then how the symbol table has been performing, just take an example. uh, Here you are given, in the example, that you are given int variable 1, then the int procedure a is there. And in this procedure you are given some variables like variable 2, variable 3. So as you can see here, the variable 2, 3, and other variable 4 and 5, you can see these are the local variables which are in the procedure a. But as you can see here, we also have the variable 1 is there, which is outside the scope of procedure A. So that's why variable A is considered as the global variable, whereas variable 2, 3, 4, and 5, and consecutively the 6, 7, and 8, these are the local variable to the procedure A. So just remember it. We are going to store these in the symbol table. So just um, see how we are going to store it in the symbol table. Then we have the procedure B. So in the procedure B, we have the procedure B's local variables. So procedure B's local variables are variable 9, 10, 11, 12, and 13. So just remember it. Now we are going to store these in the symbol table. Just check it. So represent, how we are going to represent it in a symbol table. Just see this diagram on your screen, that the symbol table global. Just we are going to form the three symbol tables in order to store these the program. So first name is the symbol table global. So this uh, in this table we are going to store the global variables. So variable 1, then the where, just remember the three attributes, or the three constructs we are going to place in the symbol table. So first is the static, that the type, then what is the type of the variable, and the third is the attribute. So so first is the variable 1, and its type is where, and it is of type int. So in the same way, in global table we have the variable 1, then the procedure A and the procedure B. And the second table contains only the symbol table for procedure A, in which we are going to store the values which are local to the procedure A. And in the third table we are going to store the values of the procedure B only, and the local variables which are which we are going to deal in the procedure B only. So as you can see here, the variable 2, variable 3, and variable 6 are at the same level. And based on this, the variable 2 and variable 3 we are going to calculate after we are going to calculate the variable 4 and variable 5. So it means the variable 4 and variable 5 are the child variables to the variable 2 and 3, and we are getting the variable c after we are going to calculate the variable 7 and the variable 8. So variable 7 and variable 8 are the child to the variable 8. So only 5 minutes are remaining. We are just concluding it in a fast mode. So in the same way, we are going to construct the variable table or the symbol table for the procedure B. So here also written that they are the inner scope of the symbol table 1, then the inner scope of symbol table 2, and the inner scope of symbol table 3. So all of you understand it till now how we are going to place the entries in the symbol table. Just write in the chat box so that we can proceed into the next topic. Okay. So moving on, the different operations performed in the symbol table. So these are some of the different operations which are performed in the symbol table. You already know that there are insert operation in the symbol table. Then as the values are filled, then the lookup and the search operation is there. Then the free operation as the symbol table is full, or if we are not using the variable again, then we can free the storage space of the symbol table, so we can use the uh, free operation. Then we can also use the allocate operation. So these are just self explanatory. So these operations we are going to perform in the symbol table. So moving on, now the storage of names. So how we are going to store the names in the symbol table? So in a symbol table, names can be stored in two ways. So first is the fixed length space. The name is there, and based on this the corresponding attributes are there. So if there is an upper bound on the length of the name, then the characters in the name can be stored in the symbol table as stated above. So you can also use this type of storage. Its name is fixed length is space. So you can also write the int means int data structure. Then if you need to store the value of a variable j, then you can write its name as variable j. Then you can also write the read array. So this is the first type of storage, fixed length space. And you can also store in the second type of way, which is known as the variable length space. So here you can corresponding to each entry you can um, make the linked list. Means if you are going to store the int, then you can write the link to the int. Then eos means end of statement is it is used as a separator between the two entries. Then the j entry is stored, then the end of statement is stored. So by this you can store the value in the symbol table as a variable length space. So moving on, so there are some data structures which are used in the symbol table. So these three data structures are used in the symbol table. First is the linear list, then the binary search tree, and then the hash table. So these are the three important data structures which are used in the symbol table. So that concludes our and I think you already studied this type of data structure in data structure and algorithm as well. So I am sharing this presentation to you for your reference, so you can go through it, and it is very easily explained. So so that concludes our fourth unit. So you need to just go through these type of data structure. Means first is linear list, then the binary search tree, and then the hash table. So all are having some advantages and disadvantages. So just go through it. I am just that linear list is of this type, as you already studied. Binary search tree is of this type, as you already know that in the case of binary search tree, the root is there. Then the left hand side is having the value less than the root, then the right hand side is having